Hello, everyone. It's Unit 5, continuation of Unit 5. We're on section 6.2, functions. Let's get started. Today's daily objective is I can write function rules. I can use input, output tables to represent functions. I can use graphs to represent functions. All right, key idea is the function rule. A function rule is an equation that describes the relationship between inputs, which we call independent variables. Okay, you're gonna need to know that. And outputs, dependent variables. So inputs, independent, outputs, dependent. So you're gonna need to know the difference between independent variable and dependent variable, okay? So inputs, which are the independent variables, go into the function. This is an illustration of a function like a machine, okay? A function machine, it's a box here. And as the inputs go in, like for instance, -2, the output is -6. Because the function rule is, if your input is -2, 3 times -2 is -6. Your output is -6. Okay, so a function rule is an equation that describes the relationship between the independent variable, or the input, and the dependent variable, the output. Let's take a look at example 1. Write a function rule for the output. Is 5 less than the input? Okay, so if you look at the words here, the output, okay, is 5 less than the input. So you need to write a equation, a function rule that describes this. So in other words, the output we're going to call y, would be the equals. 5 less than the input would be x, the input, minus 5. 5 less than the input would be x minus 5. So the function rule is y equals x minus 5. Letter B, write a function rule for the output is the square of the input. The output is the square of the input. So again, the output y is, which is equals, the square of the input would be your x, and then if you're taking the square of the input, you would square it. And that would be the function rule, y equals x squared. And that is example 1. So you're going to have some questions that you're going to be asked to write function rules. And that's what we're asked, taking the words and writing out the function. Okay. Example 2. What is the value of y equals 2x plus 5 when x equals 3? Okay, so what they want you to do here is they want you to find out what the value of the function when your x is equal to 3. So we had this kind of similarly at the beginning of the year, but as functions go, the input of x equal 3, we're going to substitute in for x the 3. So do that now. Now we're going to simplify. 2 times 3 is 6, plus 5, y equals 11. And that would be example 2. Okay, that brings us to on your own, numbers 1 through 4, let's take a look at those right now. On your own, number 1 through 4. Number 1, write a function rule for the output is 1/4 of the input. Okay, so again, the output would be y, is would be equals 1/4 of the input. If the input is here, 1/4 of that would be 1/4 times x. 1/4 times x. In general, mathematics has a tendency to become multiplication. Okay, so if remember that, is would be equal sign, of would be multiplication. Number 2, find the value of y when x equals 5. Okay, so you have your functions for 2, 3, and 4. What they want you to do is substitute x equals 5 into the function and evaluate or find the value of the y, or the dependent variable. So let's take your y, wherever x is, you're going to substitute 5 in. Now simplify. 4 times 5 is 20. Minus 1 equals 19. 19. Number 3, y equals 10 times the input, which would be 5, the independent variable 5. Y is dependent upon the value of 5. So y then is equal to 50. And then number 4, y equals 7 minus 3 times the 5. Simplify. 7 minus the 3 times 5, which is 15. Answer, -8 for on your own numbers 1 through 4. -8. Moving on to our second key idea. So keep a lookout on for these types of questions. Everyone should be able to handle that with no problem, because we've had kind of the similar exercise in the past. Okay, so what I wanted to highlight is on page 251, which is functions as tables and graphs. Okay, and I wanted to highlight that. I don't seem to have it broken. Hold on a second. Yeah, I did. There it is. It's on the bottom. I knew I had it there. Okay, so this is on the page 251. And basically what this is, and everybody should be familiar with this, it's a table and a graph. And basically it says now instead of equations, they're throwing in the word function. A function can be represented by an input-output table and by a graph. Okay, so basically what they're saying is the function can be represented by a table, which is on the left here. It's got the X column, it's got the Y column, and the ordered pair column. And it also can be represented by the actual graph of those ordered pairs. 1, 3, 2, 4, and 3, 5. So by drawing a line through the points, you graph all of the solutions of the function y is equal to x plus 2. So in example 3 now, we're going to graph a function and we're going to lay out some ordered pairs for them. Okay, so let's do that next. Example 3. Graph the function y equals the negative 2x plus 1 using inputs of -1, 0, 1, and 2. All right, let's do it this way. I'm going to have an x column, and then I'll have a negative 2x plus 1 column, and then I'll have a y column, then I'll have an ordered pair x, y. Okay, this is how I will work this. And I'm just going to, instead of putting the lines, I'm just going to put columns. So the x's are given to us as -1, 0, 1, and 2. Okay, this column you're going to substitute in whatever that x is. We're going to substitute it in. -2 times -1 plus 1. -2 times 0 plus 1. -2 times 1 plus 1. -2 times 2 plus 1. Okay, so what you have here is you have, this is what the expression is. Now we're going to evaluate the expression for the y, okay? So -2 times -1 is +2, plus 1 is 3. -2 times 0 is 0, plus 1 is 1. -2 times 1 plus 1 is -1. -2 times 2 is -4, plus 1 is -3. So your ordered pairs would be -1, 3, -1, comma 3, 0, 1, 1, -1, 2, -3. Okay, so there's your ordered pairs. Now what we're going to do is we're going to take these ordered pairs and we're going to graph them on this nice little graph over here. So we have -1, 3, 0, 1, 1, -1, and 2, -3. So I'm going to graph these out. -1, 3, -1, 3 is right here. I'm going to put a dot there. 0, 1, I'm going to put a dot there. 1, -1, put a dot there. 2, -3, 2, 1, 2, 3 would be there. And this would be the line. So what this is that we have a table of a function y is equal to -2x plus 1 that is represented by the table with x's, the evaluation, and the y and the ordered pairs. And we have a graph that also represents the function. Okay, so this may be a little bit overkill for this situation. I'm going to do a couple of them because we've done this before with graphing. Now we're just throwing in the word function, okay? So let's take a look at, on your own, on page 251, numbers 5, 6, and 7. Okay, let's take a look at those next. It says graph y equals x plus 1. And I'm going to use the same ordered pairs, -1, 0, 1, and 2. -1, 0, 1, and 2. So when I evaluate this, and I'm going to use mental math here, -1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. And 2 plus 1 is 3. Okay, so when I go to graph this, I'm going to be looking for -1, 0, which is right here. 0, 1, which is right here. 1, 2, which is right here, and 2, 3, which is right here. And then I'm going to connect all the dots up. And that's the function represented in graph format. Y is equal to x plus 1. Number 6, y equals the negative 3x. Y equals negative 3x. I'm going to again use the following x's. I'm going to use negative 1, 0, 1, and 2. So negative 1 times negative 3 is positive 3. 0 times negative 3 is 0. 1 times negative 3 is negative 3. And 2 times negative 3 is negative 6. Negative 6. And as you can see here, if you go negative 1, positive 3, you're right there. 0, 0, you're right here. 1, negative 3, 1, negative 3, you're down at this location. And 2, negative 6. 2, negative 6. You're located right there. So connecting up the dots, you can see that function, which is y equals the negative 3x, is represented by that graph. Number 7, y equals 3x plus 2. So again, I'm going to use the same x's, negative 1, 0, 1, and 2. If I'm looking to graph this function, I'm going to first multiply the x by 3. 3 times negative 1 is negative 3, plus 2 is negative 1. 0 times 3 is 0, plus 2 is positive 2. 1 times 3 is 3, plus 2 is 5. 2 times 3 is 6, plus 2 is 8. And those would be your ordered pairs. Negative 1, negative 1. 0, positive 2. 1, positive 5. And 2, positive 8. And it's a line going right like this. And that would be the graph of the function y equals 3x plus 2. So this should not be anything really new, good review, but we're throwing in the word function in this section. Okay, now we're going to move on to our last example for this lesson. It's example 4, and it's under the real life application with regards to 6.2 and functions. Okay, so the number of pounds, P, of carbon dioxide produced by a car is 20 times the number of gallons, G, of gasoline used by the car. Write and graph a function that describes the relationship between G and P. Okay, so I did a little bit quick. I wanted to show you the graph here. So I snipped the graph out of the book, and I've got it on the lesson for you to look at. So if you look at the x-axis, the input, which would be G, okay? So G is the input, the independent variable. The output is the P. So P is the output, is equal to 20 times G, the input. Okay, so 20 times the gallons. And as you can see, what I did is I've got your G, the input, P, the output. G is independent, and the carbon dioxide is dependent upon the number of gallons. Okay, so that's where those independent and dependent come in. Inputs are G. Pounds are dependent upon the number of gallons. Okay, so if you look at 1 gallon, 20 pounds. 2 gallons, 40 pounds. 3 gallons, 60 pounds of carbon dioxide. And the graph is located right here of that function. So when you plot the ordered pairs, you draw the line through the points, the ordered pairs. And we only are going to be working in this quadrant one. Quadrant one, because you cannot have a negative number of gallons of gas, okay? You only use positive numbers of gallons of gas. And that's example 4. So we're going to conclude this lesson with our last on your own, and it has to deal with the example that's above here. And it says, for a truck, P, which is the pounds, is 25 times the G. Write and graph a function that describes the relationship between G and P. What I thought we would do is first, let's write the function, and then we'll graph it right on the same graph, okay? So in this case, P, pounds, would equal 25 multiplied by the number of gallons, okay? G. So P equals 25 G. So if you have 1 gallon, you would have 25 pounds. Two gallons, 50 pounds. 3 gallons, 75 pounds. So those would be the ordered pairs. All right, so let's graph those out. 1 gallon, we're at 25. 2 gallons, we're up here at 50. 3 gallons, we're at 75, which is right up in this area. So if I connect these dots, whoops, a little crooked there. Whoops, oh, okay, there you go, you get the idea. It is a graph that sits slightly above the other graph for on your own number 8. Okay, so in summary today, I'm looking at page 252 in summary, representations of functions. First, we can represent a function by the use of words. Okay, so this example 4 and on your own number 8 are good examples of that. 20 times the number of gallons P. We then can show functions by the use of an equation. In this case, P equals 20 times G. We also can show functions by the use of an input-output table, similar to the one we drew in example 3, an input-output table. We also can represent functions by using mapping diagrams. Mapping diagrams. So you could take your hockey rink 1 and hockey rink 2, and you could map the function -1 goes to 3, and 0 goes to 1, and 1 goes to, maps to -1. And lastly, you can represent functions by the use of a graph, by use of the graph. So words, word problem or whatever you're describing, words, an equation, which would be in this case, y is equal to -2x plus 1, an input-output table, a mapping diagram, and a graph are all representations of functions. So this concludes the lesson today on 6.2, representations of functions. Hope you found it beneficial. Keep a lookout for the question of independent what's independent. I always like to think of I inputs. Some people will just say, oh, it's independent, it's got to be the X. Okay, dependent is the Y output. You're going to want to know that in upcoming questions. And hopefully you found it informational, and we'll talk with you soon. Thank you very much for listening.